First, I will show you the map for visualization. You can choose between train, tram, bus, and the overall public transportation data that combine them together. Since my main focus is on the train cluster, I also add the train station data for reference. If we click on the train data, you can see that points having the same color belong to the same cluster. And the gray points are those failed to be classified into any cluster. If we turn the train station data on, you can see in general the data spread along the train routes. And many clusters are located at or near train stations, which makes sense. You can click on any point within the cluster and see its brief summary. For example, here's Flinders Street. Number of posts 457, and the total 10 keywords people use with their frequencies. In this way, you can have a general idea what people are talking about in that cluster. And there are also many stations identified outside the CBD area, like Richmond, or even more far away like Jewel, Brunswick, and etc. For the train data, unfortunately, there's no clear pattern. Most of them are within or around the CBD area. You can clearly see the Swanston line, the Southern Cross line, and there are quite a lot near the Parliament station. For the bus data, the quantity is just too small, so I just ignore it. And last is the clustering map combining all public transportation data together. Because train and train data are added, so basically a large proportion is crowded in CBD area. That's why you can see they are in the same color. Now, let's turn to the website displaying statistics of my project. It fetches data directly from CouchDB. Since you have seen the first section already, so I just skip it. The next section shows the prediction accuracy for train stations, based on filtered train and train station data. Here minimum samples refer to the mean samples parameter I have already explained in the slides. X-axis is the epsilon value in dB gain. I chose its range from 50 meters to 500 meters. Y-axis shows the prediction accuracy. You can see that in all four scatter plots of different minimum samples, the accuracy is stably higher than 55%. From 3 to 10, it can be roughly figured out that more samples, high accuracy. And the accuracy declines when epsilon gets bigger, except these plots, which are called with our common sense. The last plot shows the relationship between the total number of clusters and the correct number. Whether a cluster correctly identifies a train station depends on the distance between its centroid point and the nearest train station. If within 250 meters there exists a train station, then the mark it as correct. You can see the linear relationship here is pretty clear. More clusters, more train stations identified. So based on these plots, we can conclude that predicting train station from social media posts is actually doable and trustable to a large extent. The last section shows the ranking of train stations that have been correctly identified. There's no surprise that Flinders Street has the biggest cluster size, and follows like Southern Cross, Melbourne Central, and Flagstaff, which are all in the CBD area. But you can also find stations like Richmond, North Melbourne, and not. What surprises me is small stations like Thomastown can rank so high. So I checked what actually these posts were talking about, and found out that they were actually posted by one account. Similar situations happened to Sando as well. What these posts said were just, I'm at blah 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 station, followed a Foursquare link, and they were posted on Twitter. So I guess there are certain people who have this kind of habits like checking online once they travel by train, which is kind of interesting.